stop it. The packet? So what can I go over? So the algebra on the year is actually like 5.9. So after I take questions on the graphing ones, I'll do one or two of the algebra ones, which also gets you started for 5.9. Yeah. So what can I? There's got to be questions. Say one. Oh. I was like, yeah, just said what the hell. 20. 20 I can write. 20. 1. Okay. So this says count the points of inflection. I'm gonna ask this question again with a different twist after I go through this one too. So count the points of inflection between 2 and 7. So we're only looking between there and there. And what I did was just like kind of sketch out the concavity, the curves of it. So there's concave up, and there's concave down. So like somewhere in there it's switched. So there's 1 point of inflection. Curving down, and then now it's curving up. So it's I don't know exactly where, but somewhere around there it's switched. And then it's curving down again. So I've got a switch somewhere around there, somewhere around there, and somewhere around there. So there's 3 points of inflection because there's 3 times that the graph changes concavity. Yeah. Got it up?
Yeah. Thank you.
Alright, I want you to do it again, regardless because no one's done this question. Let's say this is f prime of x. Same question. How many points of inflection does f of x have on this interval? If that's f prime, don't say it out loud. Think about it. Look in your chart if you need to, whatever. But, if that's f prime, how many points of inflection does f have between 2 and 7? So you can get out that little table and look up like f prime graph points of inflection. See what you get. You should write it down. We good? Can I go through it? What's the answer? 2. Good. So you're looking for, in this case, you're looking for peaks and valleys. So there'll be a point of inflection there and a point of inflection. All right, start it over. What if it is the second derivative? How many points of inflection does f of x have? And then like, try to know where they are. So the second derivative tells you concavity, right? If the second derivative is above the axis, the original is concave up. If the second derivative is below, the original is concave down. So when it crosses the axis, those are points of inflection. So there'd be 2 there as well. Just a different 2 than the one before. Is that right? All right. What else? What else? I know someone else. So go ahead. Sorry. 21. The graph of the derivative is shown above. So this is f prime. Which ones of below could be f? Okay. So I think I would start by looking, if this is f, where is the slope of this? I always start by like, where's the slope 0? So where is this, if this is f, if this were to be the correct answer, the slope is 0 between 4 and 8, right? If this is f, the slope is 0. So I would need the derivative to have a value of 0 between 4 and 8. And it doesn't. Like if this is my original, my derivative should just be a flat line at 0, representing the slope of 0 at that spot. So I'm going to cross off that first one. This has a slope of 0 at 3 spots. This has a slope of 0 here at 1, here at 3, and I guess that's at 6. So the value of our derivative at those spots should be 0. Is that true? It is. So that's a candidate. It doesn't mean it's right, but I'm just going to like see if that eliminates what I need to eliminate. This has a slope of 0 here at 1, here at 3, and here at 6. So then I'm still kind of stuck on, is it 2 or is it 3? So they're both the same shapes, right?
Yeah.
The only difference is this one doesn't connect and this one does connect. Is it 2 and 3? Is that the answer?
Yeah, that's it.
So they're both the same shape because the slopes all match up. And does the derivative exist there? Nope. Does the derivative exist there? No. So in either case, you're going to get like that separation. So it is 2 and 3 because the shapes both. I forgot who asked that. Is that good? Thank you. Start giving bonus points for asking questions. What else? 23 you were asking about before, right? So 23, and again, I'm going to go through it a little bit more than just like the question they're asking. If I were to ask you, so this is the derivative, this is f prime. If I were to ask you what type of point is A on the original graph, what would you tell me? A what? Okay. Be more specific. It's a relative min because the derivative is negative here, which means what's the original function doing? Decreasing, and then the derivative is positive, which means increasing. So doesn't that have to be the spot where it switches? That's a relative min. So then, probably a little easier now, but what's that one? That's a relative max because it's the opposite. What is that? Like the very peak there. And a derivative graph, if you're looking at peaks and valleys, what are you looking at? Point of inflection. So this is a point of inflection. And I think that's the one they're asking about, right? I think that's the answer.
Yeah.
So this is wrong because A is wrong because it's really a local max. B is wrong because what they're trying to get you to do there is like, forget it's the derivative and just be like, well, yeah, that graph is tallest, that's the highest there, so that's a local max, but we're not looking at the original graph. And then, yeah, so D is correct. Is that all right? Like Matthew asked earlier, we just talked about it already, but so I'm kind of answering his questions that he asked before. Is that okay? What else we got? Remember, this will be like a pretty decent chunk of your test, questions like this. If you don't ask, I'm assuming we're good. Maybe you are. Yeah. 20. You're okay. this is the original graph, and I'm looking for points of inflection. So I'm looking for where does the concavity change from like curving up to curving down, or vice versa. So I just kind of drew the curves, like that's going up, that's down, that's up, and then that's down. So how many times does this switch? Well, it switched once there, once there, once there. So there's 3. Is that right? Yeah. So, we'll wait 7 seconds.
26.
What?
26.
Oh, that was magic. Yeah, say 7 seconds. So they're saying, I can't really show all the answers, so let's just like talk through. F of x, f prime of x, and f double prime of x are all negative. So what does f of x being negative mean you're looking for on the graph? Below the axis, right? So like in the bottom half. So I need to be below the axis. F prime being negative means the derivative is negative, means that what should be true on the original graph if the derivative is negative? Negative slope or decreasing. And then if f double prime is negative, what does that mean? Concave down. So I've got my negative slope and concave down. I know from my like pieces, that looks like that. And then I've got to be below the axis as well. So I've got to have that shape below the axis so that lands us at B. Good? All right. 27? Alright, so this is the derivative. This is f prime. So let's just talk about what's happening for a minute before I get into what's answering the questions. What is going on in the original graph here? Say it again, no? The original graph is increasing, and then over here, the original graph is decreasing. So what is this point? A relative max, because we switched from increasing to decreasing, right? We went from going up to going down, so that creates like the top of the hill. So that's a relative max. I don't know that this is what's happened, and I can't assume that, but let's just like kind of pretend that this went like that, and this went like that. What would, if that were the case, what would both of those points be on the original graph? Points of inflection, because they're peaks and valleys on the derivative. Right? I know that's not what they're asking. Okay, so number 1 says f is continuous between a and b. Well, remember that one of the rules that says like you can only take the derivative if the original function is continuous. Like that's a requirement to be able to take the derivative. We clearly have the derivative, like for that entire thing, so it must have been continuous to begin with. Does that make sense? You can't take the derivative unless it's continuous. Well, I see the derivative, so therefore it must have been continuous. So that's true. And it doesn't say anything about like to the left or right of A and B. It's just saying like between there and there. So just in this little spot here, we know it's continuous because I can see that the derivative exists that whole time. F is decreasing between A and B. Well, we just said F is increasing here because we're above the axis. It's decreasing here because the derivative is below, but here it's increasing, so that doesn't count. And then concave down. Well, concavity comes from f double prime. I've got f prime. So what do I think about to go from f prime to f double prime? The slope or the derivative, right? Well, isn't the slope here negative the whole time? So if I've got a negative first derivative, or negative slope on my first derivative, doesn't that mean the second derivative is negative? So if the second derivative is negative, doesn't that mean concave down? And it's those two. How's that one? What else we got? So we got to put these in order. So these are all, I was just checking, like, are we looking at the original or the second derivative or the first? These are all looking at the first derivative. So if I'm looking at, this is f. So how do I take the derivative of a graph? I'm going to look at the slope of it, right? So at -2, so f prime of -2, I don't know what it is, but that's a positive number because it's going up. F prime of 0 is going to be 0 because the slope there is flat. And then f prime of 3, I don't know what number it is, but we're going down there, so it's a negative number. So if I've got to put them low to high, it's going to be the negative, and then the 0, and then the positive. So that matches up with that. Alright. Others? Yeah, well. Yep. So that's the second derivative, and I'm looking for the original. And I'm going to scroll like 4 pages worth to see what they look like, right? Are they like giant graphs? Okay. Oh, are they? So what I know is the original graph needs to be, if I could, like, here, I'm going to do this with a marker so it stays when I scroll. So at like 1 point, or 2.1, there's a change, and then at like 3, 4, so 5.2, there's another change. This is the second derivative, right? So what do I know about the original graph over here? Since the second derivative is above the axis. Concave up. Here, concave down. Here, concave up. So there's got to be a point of inflection at 2.1 and 5.2. I don't know if that's enough to get the answer or not yet, but let's check that. So this one does not change concave. Like, is there a point of inflection on this graph at 2.1? Is that a point of inflection? It's not. That's like a relative max. So that's not it. Or, oh, did I skip one? So here's 2 point whatever. So this is concave up until 2.1. That looks good. Concave down until 5.2. Yeah, I don't like that anymore. No, I'd say this is concave up until like here, wouldn't you? So concave up and then concave down. So that doesn't match up. So C does work because I've got like concave up until like right here, concave down up until like right here, which is your 5 point whatever, and then concave down. But I can't see the other ones. Are there other ones where the concavity fits? This is really annoying. Just gigantic graphs. So is this the? Am I on the right? This guy. That's just got way too much concavity going on. Like it's gotta give up to here, and then down, and then up, and then down, and it switches like way more than we want it to. So C was the red one. Sorry, that took like 10 minutes to go through. Does that make sense? Okay. So this one is an algebraic one, which we're going to get into more today. But let me just talk like in general what I would do. I don't know if I'll do the whole thing, but I'll get it started. So one relative min and 2 points of inflection. What level do relative max and mins or extremums? What level do those come from? They come from the derivative level. Remember the quiz I gave you? You had like the HA and VA were on top, they came from the original. And then there was a chunk of like increasing, decreasing, relative max, relative min, and those all came from the derivative. And then the second derivative was concave up, concave down, points of inflection. So the first derivative tells you relative max and relative min, which is relative extrema. And then the second derivative tells you points of inflection. So what I would do is take the first derivative, which would be like 4x to the third minus 6x squared. Set that equal to 0 and solve. So I can take a 2x squared out of that. I'd get 2x minus 3 equals 0. If I solve those pieces, I'll get x equals 0 and x equals 3 halves. And then I would set up, remember that chart? We'd go negative infinity to 0. 0 to 3 halves. I'm kind of running out of room, but is that familiar? Do you guys remember doing that on the take-home quiz? And so I don't know what it. So okay, this would be negative, negative, and the last one would be positive. So if there's one time when it changes, which gives you is what gives you the one relative extreme. Then I would do the same thing on the second derivative, which would be 12x squared minus 12x. I can set that up, get my 2. I'm rushing through it because we're going to do this in a minute, and this is not like the best example of it. So I'm trying to answer your question without taking too much time on what I think is not a great example. But then I would set up my intervals again. Check like negative infinity to 0, 0 to 1, 1 to infinity. And anytime it changes signs, it's a point of inflection. So it's really just kind of taking what you did on your quiz and asking you to summarize it and do it like kind of quickly, I guess. Is that a decent answer? Yeah. Alright, let's go to number 1. Let's do number 1 on here, which is an algebraic one. So it's exactly like this one. And it's really what you do in your quiz. It's just a matter of like organizing it. But I'm going to show you like a shorter way to write it now that you've done the whole quiz thingy. I want to know when this function is decreasing and concave up. So again, what level would I look at to find out where it's decreasing? First derivative. Or what level would I look at for concavity? Second derivative. So the first derivative was that 2x to the third. Is that what that says? 6x squared minus 6x minus 12. I'm going to set that equal to 0 to get my critical points. I can take a 6 out. And then I can factor. So what multiplies to be -2 and adds up to be -1. -2 and 1, right? So x minus 2, x plus 1. And then I take each of those separate pieces and set them equal to 0. So 6 equals 0 never happens. This will give me x equals 2. And this will give me x equals -1. So we used to make that chart. So don't write this down, because I'm going to show you like a faster way. So we used to say x, and then like the sign of f prime, and I would put negative infinity to -1, and then I'd put -1, and then I'd put -1 to 2. You know what I'm talking about? So a much faster way to do that, because they're not asking you to justify anything here. I'm just going to make a little number line and put -1 and 2 on the number line. And I'm going to pick a spot, and then look over here is like negative infinity. I'm going to pick a number 2, and you can plug it in here or here. I think this is easier. If I plug in a -2 here, negative, right? If I plug in a -2 here, negative. So then if I multiply that all together, isn't that positive? Which means the original graph is increasing, right? So I'm just, the number line is just like a shorter version of that big chart. I would pick maybe 0 here to plug in. If I plug in 0, it's probably easiest to use this one because it's just 0, 0, -12. That's a negative number, so we're decreasing in that window. And then from 2 to infinity, let's say I plug in 10. If I plug in 10, all 3 of these parts are positive. So I get a positive derivative, which means increasing. Look at that. We see how that's just like the box, but way simplified down faster. Okay. Now I gotta do the second derivative. So concave up comes with the second derivative. So the second derivative is 12x minus 6. If I set that equal to 0 and solve, I will get 1/2. Now there's only 1 point on my number line. And I'm going to pick a point from those regions, left of 1/2 or right of 1/2. And I want to know about concavity, so I plug into where? I plug in the second derivative. I plug into where it just came from, basically. So like if I plug in 0 to the second derivative, I get a negative, right? 0 minus 6, so then it's concave down. If I plug in like 10, I would get a positive, so concave up. And so what a lot of these questions will ask you to do, and this is what 5.9 is about also, is just kind of summarize those. And you guys did this on your take-home quiz also. Put any critical point that you got from any level on your number line. -1, 1/2, 2. Put them in order. Load high. This is like my final summary. And then I know increasing up until -1, decreasing from -1 to 2, well, that's both of these. So -1 to 2 covers both. So I'm going to say deek, deek. And then ink over here. And then on the bottom, I'm going to put the concavity. So we're concave down all the way up to 1/2, which is both of these intervals. And concave up after. And so what the question is asking now, they can ask you anything. Like now you have it all organized. So where's the decreasing and concave up? It's just where both of those are. Wait, sorry, I circled the wrong freaking thing. That's all that work. It was like, no, it's obvious. Just look. And then I circled the wrong thing. So decreasing and concave up is there. Is that alright for that one? That makes sense what I'm doing. Another thing they get into is speeding up and slowing down. Remember, speeding up means velocity and acceleration have the same sign, which means the first and second derivative have the same sign. Slowing down means velocity, acceleration, or first, second derivative have different signs. So see if you can go through this number line and tell me in all 4 of those intervals whether we're speeding up or slowing down. There should be 2 of each. Are you guys with me about me to keep going? I feel like I'm going too fast, but okay. So it might be helpful to just kind of like write yourself a little increasing, the first derivative must have been positive. Concave down means the second derivative must have been negative. So in this interval, we are slowing down. This would be negative, negative, so speeding up. This would be negative, positive, so slowing down. And this would be positive, positive, so speeding up. Is that all right? How many algebra ones are there on? You got the numbers? What are they? 13, 14, and then 17. Do those. Let's do those right now. That's what I want you to do right now. 13, 14, 17. All right, so here's what you got. I put these in weird order, but I want you to do these three right now so you can like check them, ask me questions if you get stuck. But I basically just taught you 5-9. Like those three problems are 5-9. So I'm not going to give you like a class period to do that because we're practicing it right now anyways. So do that at home. I will answer questions on it. But again, keep in mind if you don't ask me a question, I'm assuming we're all set and we're going to just keep rolling. And do the 5-10 video also. Fair enough? Test is probably next Friday. I think yesterday I had Thursday up there. Next Friday. Why did you make that face? Oh. What's that day?